Hello everyone. Today I'm going to serious do something regarding diploma program past paper, physics past paper. I want to share you something how to solve question in the physics standard level paper 2. This is in 2019. uh, Only a few numbers I want to share you. Yeah, this is paper 2 standard level. um, Okay, we go directly to solve this problem. The first question is a student strikes a tennis ball when it's initially in rest on the left liquid at the speed of 64 meter second minus 1. The ball has mass 0.058 kilogram, and contact between the ball on the racket lasts for 25 milliseconds. Calculate the uh, question 1 average force exerted by racket on the ball. Yes. uh, this is about the momentum uh, impact on the ball. So we have a formula for this. This is actually about impulse. Impulse as F times T equals to uh, change in momentum or mass time with velocity minus velocity. That this is final velocity minus initial velocity. So if we calculate this, yeah, this is the force is this is what I find, what we will find, and T is 25 millisecond. If we change into second, divided by 1000, this is equal 0.025 second equals to mass is 0.058, and times with velocity, final velocity is 64 minus is initial is, because this is rest, so this is equal to 0. So if we calculate, uh, about the 0.058 times with 64 is equals with 3.712, and divided by 0.025, yeah, this is equals to 148.48. Yes, this is about 148. F equals to 148.48 Newton. Yes, this is the answer for the question 1. So continue to next question. Average power delivery to the ball during impact uh, power that's power is work done, yeah. Power in P equals to work done divided time, or power equals to the work done means kinetic energy change, yeah. Kinetic energy, the second one, minus kinetic energy, the first one. Then, uh, sorry, this is divided by time, yeah. So, because the ball in initial rest, yeah, the velocity initial rest, that's become, this is about a half v square, and minus 0 because from rest, and divided time, so we get p equals to a half of mass is 0.058, and velocity is 64 uh, square, yeah, and divided by time. Time is 0.025, and if we calculate this, yeah, I calculate first 64 times 64 times 0.058 kilogram as mass, and divided by 2, and this is the kinetic energy of the final position, and we divide it by time 0.025. Yes, we get 81,921 watt. 81,192, 81,921 watt. Yes. Okay, this is the answer for the power. Yeah. The power is around 81,920 watt. Okay, the next question. Wow, this is other condition, yeah. The student strikes the tennis ball at the point P. The tennis ball initially directed on the angle 7 degree to the horizontal. The following data hit P is 2.80 meter, initial velocity as 64 meter second minus 1, the angle between horizontal line 7.00 degree, and the net is in the height 0.910 meter up the ground, and distance between ball horizontally 11.9 meter. Okay, the question is, calculate the time the tennis ball to reach the net. Okay, before we go directly find the solution, we need to know about the velocity on the x direction and velocity on the y direction, We draw it first. This is the velocity. Velocity. Oops. Sorry. I draw it first about the vector of velocity on the x direction. Yeah. And we have velocity on the y direction. Okay. This is 64 cos 7 degree velocity on the x direction, and also we have velocity on the y direction. This is 60 sine 7 degree. Okay, until we know about the vector velocity on the x direction and the y direction, uh, we go to the question. The question about time, yeah, until the reach net. So we have distance here 11.9, yeah. So in the x direction, because there is no acceleration on the x direction, directly the distance equals to velocity times t. The distance, velocity times time. So the distance is 11.9, 11.9, and velocity is 64 cos 7 times t. Yes, we get t. We calculate first. This is 11.9 divided by 7 cos 0.99 times 64. This is around 63.5. So we get answer is 11.9 divided by 63.5. Yes, the answer is 0.187 second. Yes, this is the time. How long until reach the net? Yeah, this is around 0.87. Okay, continue to the next question. So that tennis ball passing over the net. Uh, we draw first about the distance, yeah, between in this. The distance between this side, this is equally um, 2.80 minus 0.910. The distance here, or we calculate here uh, 2.8 minus 0.910 equals to 1.89. So here is 1.8, sorry, 89 meter. So this distance, yeah, the distance, we will find, is it above of this distance or no? If the question I, so the tennis ball passes over the net. Okay, this is about the y direction. That's y equals to, oops, y is, this is velocity on the y direction is 64 sine 7, that times t plus a half gt square. Why we use positive? Yeah, because the ball going down. Yeah. So if we calculate this, this is y equals to 64 sine 7. We find first by my calculator. Yeah. Wait. Sine 7 times 64 times t. Yeah, this is 7.7, this 0.78. T is 1 point, oh, sorry, 0.187, yeah, plus a half of g. Let's say g is 9.81 times t is 0.187 square. So if we calculate this, yeah, 7.8 times with 0.187, it become 1.4589 plus 0.87 times 0.187 times g is 9.81, and then divided by 2 because a half. Yes, this is about 0.1715. So the y is 1.4586 plus 1.4586 0.86 plus 0.05 0.071, so we get 1.63 meter. So if we know, yeah, this number, yeah, if we copy this is the sun on the y direction. Yeah, oops. This is the y direction on the when the ball coming down. Yeah, this is 1.63 meter, and this is 1.89. So the ball is passing, because if we know this is the position of ball, yeah, a little bit up, then net. Yes, this is between net and ball horizontally. Okay, this is proven. Yeah. No. Question three. Determine the speed of the tennis ball is the strikes the ground. Okay. Speed. We can use about the formula. Then v on the ground square, that equals to v initial square and plus 2gh. So we get the vg vg. This is root of the value here. Yes. So vg is root of, this is 64 square plus 2 gs9.81 times, yes, h is around 2.8 meter. So I want to solve this by uh, using my calculator. Start from 64, 64 times 64. This is around 4096 plus 2 times 9.81 times also with 2.8. Yes, this is 54.936, and we plus with 400 096. Yes, this is around VG root. If we root it, yeah, if we root it, wait, yes, we rooted 64.43 meter second. Okay, finally we get the velocity when the ball hits the ground. This is around 40, this is around 64.83 meter second. Okay, let's continue to the next question. I think we need to skip this because, as I mentioned before, I only solve a few numbers, and I will skip about the theoretical. Yeah, we directly to the other question. Yeah, this is the question two. Before we continue about the question two, don't forget to subscribe my channel, like and comment. Okay, we continue the question two. A container volume 3.2 times 10 minus 6 meter power 3 is filled the helium gas at the pressure of 5.1 10 to the power 5 Pascal and at temperature through 320 Kelvin. Assume that the sample of helium gas behave as ideal gas. Okay, A. The molar mass helium 4 gram per mole, so that the mass helium atom is 6.6 times 10 minus 27 kilogram. Okay, the mass is, we have mole, yeah, and we use the Avogadro one, yeah, that mole is, mass divided mass relative, yeah, so this is about the uh, Avogadro. Oh, sorry, we have 4 gram per mole and, oh, forget. Uh, the mass is, this is 4, no, 4 times with n kilogram is 10 to the power of minus 3 per mole. Then we divided by Avogadro number 6.02 times with 23. Yes. And yes, actually we have mass equals to, this is 4 divided by 6, yes, around 6.6, 6.6 times 10, yes, because this is minus 3, this is power 23. If the going up, this is minus 26, but this is actually 0.66. Yeah, if okay, we draw, this is 6 point, and then this is 10 to the power of minus 26. So its main uh, mass is 6.6, but the power is minus 27. Then in kilogram. Yes, correct. Finally, we get the answer. The correct answer, the same thing with 6.6, 10 to the power of minus 27 kilogram. Continue B question. Estimated the average speed of helium atom in the container. Yeah. Speed by, oh, we use the formula that V equals to root of 3, um, oh, R T divided by M moral. Then V equals to root of 3. R is 8.314, and T is T2 Kelvin. Then divided by molar, mass molar of helium is 4 gram. Yeah, but this is in kilogram. 4 times 10 power minus 3. Okay, this is, if we calculate this, yeah, we 3 times 8.314 times 4 times 10 to the power of minus 3, 0.001. Yes, this is around 0.099. Yeah. Root of 0.099768. So V equals to, after we wrote it, uh, 0.3 something 15 meter per second. Okay, thank you very much. I will continue to the next number. I will stop this video first, yeah, because is it so take a long time, and I will continue to the next number in the next video. So please don't forget to subscribe my video. Don't forget to subscribe my video, like or comment and everything to see if my video is still any some mistake. Okay, thank you very much. And if you want to see my face, this is my face. Okay, bye bye. Thank you very much.